Optoelectronic systems could reduce size and energy requirements for data centers. Advanced hardware holds the key to overcoming dynamic bottlenecks in autonomous systems. And a laser-driven approach to imaging fully rotates complex samples without touching them. All your industry headlines are on Photonic Spectra Now. Photonic Spectra Now is brought to you by Flux Technology. See above the noise. Visit fluxtechnology.com to learn more. This is Photonic Spectra Now, covering all the latest news and developments across the industry. I'm Joe Kaczynski, Senior Editor with Photonic Spectra. We begin with some breaking personnel news as Optikos, a provider of engineering, manufacturing, and metrology expertise in optical systems, has named Rudi Coetzee CEO. Coetzee will take over for founder Steven Fantone, who now serves as strategic advisor and board chair emeritus. Fantone transitioned into that role last month when private equity firm Artemis acquired Optikos. Coetzee has served as chief operating partner for Artemis, joining the firm in 2019. He has more than 20 years of experience in business leadership with a background in engineering. A newly developed, reconfigurable germanium-silicon photodetector from Shanghai Jiao Tong University aims to reduce parasitic loss in optical interconnects. And at the same time, the device is showing promise as a mechanism to improve signal integrity. The growth of language models has placed an increase in demand on data centers to deliver higher bandwidth while maintaining low latency and energy efficiency. Improving optical-electrical integration in large-scale computing environments could help. Using a low-loss integration strategy based on fan-out wafer-level packaging, researchers have enabled the seamless integration of electronic integrated circuits and photonic integrated circuits on a single platform without the need for traditional wire bonding. This approach optimizes energy efficiency and a compact form factor and could offer a pathway to scalable optoelectronic systems for our data-driven needs. Hamamatsu Photonics is establishing a subsidiary in Singapore to strengthen its business foundation in the Southeast Asian market. Officials with Hamamatsu say steady economic growth is expanding the manufacturing market in Southeast Asia, and this new base will help them to speed up lead times and cut costs to customers in that region. Operations are scheduled to begin in October of this year. In market news, Arkeus, an Australia-based developer of sensing systems for defense applications, has raised more than $17 million to accelerate the development and deployment of its AI-powered sensing systems designed for autonomous platforms. Arkeus will use these funds to establish advanced manufacturing facilities in Queensland, Australia, and in the US. This move will help the company to deliver its systems to Australian and American Departments of Defense, both of which it has existing contracts with. Hellbender, a robotics engineering and hardware firm specializing in physical AI infrastructure, has closed a $12.5 million seed funding round to expedite the rollout of its edge AI platforms. These platforms are designed to bring real-time perception, reasoning, and decision-making directly into physical environments. After years of engineering custom edge AI computer vision for leading robotics companies, Hellbender says it is now targeting the development of universally accessible platforms, addressing a current bottleneck in autonomous and industrial systems. Quantum error correction and quantum computing company Qauntique has received $30 million in investments to support its journey towards fault tolerance. Qauntique is focusing on utility-scale quantum computing with the ambition of building fault-tolerant quantum computers by 2030. The quantum company leverages bosonic codes and multi-mode logical qubits to correct errors at the qubit level. This $30 million brings its total valuation to $1.4 billion. And in research and development news, from the Karlsruhe Institute of Technology, a new laser-based approach is enabling the 3D rotation of microobjects in fluidic media. If you're active in the medical research community, you may already know the significance of this advancement, but if you're like me, you may be asking, why does it matter? Well, until now, it has been virtually impossible to rotate sensitive samples in all directions under a microscope without making contact that could damage or alter the sample. By using a laser to heat the liquid around the suspended sample, researchers were able to gently move or rotate the sample in all directions without manipulating it directly, improving the 3D imaging of cells and other biological structures. In one cellular experiment, they were able to detect 2 distinct nuclei in a sample that had showed just one in conventional imaging. The approach provides a new micro-scale flow control strategy for micromanipulation in the life and engineering sciences. More broadly, the ability to move samples in 3 dimensions via a contactless method could also be used for microscopic robotics and manufacturing on the smallest of scales. That's why this matters. You can send any story tips to video@photonics.com, and be sure to visit photonics.com for complete coverage on all the headlines from our industry. Before you go, click that subscribe button in the corner for notifications from the Photonics Media YouTube channel for new episodes of Photonics Spectra Now and the very latest recordings of the All Things Photonics podcast. I'm Joe Kaczynski, and thanks for watching.